Welcome to today's video. If this is your first time joining us, I will encourage us to subscribe to the channel. Currently, we're looking at the lead code patterns by Shane Prashad, and today we'll be looking at the reverse linked list algorithm. I do hope we enjoy it. Let's get down to the algorithm question now. So we are told that the reverse linked list is the question, and the question says, given the head of a single linked list, we are to reverse the list and return the reversed list. So for example, we have 1, 2, 3, 4, 5, and we have to return 1, 2. We have to return 5, 4, 3, 2, 1 basically. 1, 2, and we have to return 2, 1. If it's empty, of course, we return empty. And the number of nodes in the list is, so we can have nothing there, or we could have up to 5,000 items there, and the value is between minus 5,000 all the way to 5,000. So we are told that a linked list can be reversed either iteratively or recursively. Could you implement both? For sake of time, I think I will just go with the iterative. The recursive will be an O of n. I don't think there's a way we can do without, since recursion will always stack up. So maybe we just do the iterative, and if we still want to do the recursive, you can drop it in the comment section, and I will surely do make a video on that. So let's look at the board and see how we go about that. So here we are given our linked list as normal. So 2, 3, 4, and we have 5. So we have 1, 2, 3, 4, 5. One approach is that we could just form a dictionary, a list, and like an array. So we just have 1 to populate the array, 3, 4, and 5. And then from the array, we start going backwards and start creating new nodes. Since we have, for example, if we look at the definition there, we have a node and we are constructed. If we pass in a value and a node, it knows that that will be next, or we could just pass in a value and then we put in the next property later. So we could use that approach, but that will be an O of n because we will need to create an array. So that will give us a space of O of n. But I think we could do this in place. That means to give us a space of 1, because we will not be using an extra space. We will just use, we'll be changing it inside of these places themselves as it is. And let's just see how we can achieve that. So let me just clean this up. So thinking about this, actually, I think it's best if, for the approach we want to do now, to write the code out, and then when I'm explaining, it will make more sense that way. So what we'll do, we will have a previous set to null. We have, okay, but so since it's going to be null, it doesn't know what type it is. So let me set it to list node so that it knows it's a null type of list node. And so what we just do actually is just, we'll be checking while our head is not null, and so we just have a temporary value where we just put what is in the next of our head, and then basically just replace that what is in next with what's in previous. Then we replace what is previous with what is in head, and then we'll replace what is in head with what's in our temporary storage, and then we just return previous. Now I promise this will make sense when I start to explain. Actually, if I try explaining this before I write it, I feel it will be a little bit vague, and we will not understand why it is going that way. So I felt I should put this down, and then we look at how it will look on the board. Yeah. So here, back on our board, and let's just have our node again here. 1 pointing to 2, 3. Let's just have it to 4 for simplicity's sake. And what we are trying to achieve here is we want to do it in place. That is, we are trying to replace it on this same location. So what, with the approach I said earlier, we will need to create new nodes, and those will have new locations, new memory locations. But what we want to do is, on the particular locations this nodes actually exist, we want to replace the values within those locations. So that is how we can achieve an O of one space complexity. So what based on what I had written previously, so this is our head, and then we have our previous set to null. So let's just have here, and then we have our first iteration here. So we have a variable called tmp, temporary, that we hold that we hold what is in the next of our head. So for example, that is 2 pointing to 3 pointing to 4. Basically, that's what is on our temp. Now we have our head, and we are replacing what is in the next of our head. So currently what's in our head is 1, but we're replacing what is in the next, which was 2, with what is in previous, and previous is null currently. So this is what we have in our head. And then we went and we are replacing what is in previous with what is in the head, and what is in head is same as what is here now. And then we are now changing what is in our head and setting it to what is in our temporary, which is 2 pointing to 3 pointing to 4. So that's for the first iteration. So these are basically the 4 steps we went through for our algorithm. So in our next iteration, let me just cut this out here. In our next iteration, we have our TMP. Our TMP, don't forget, is what is in our head, the next item in our head. So our head is 2, but the next is going to be 3 pointing to 4, right? Now, our head, we come and replace what is in the next. So what is in our head is actually 2. What should be in the next is 3. But what we are now doing is what was in the previous, we are putting it in the next. So in the previous, before, we had 1 pointing to null. As we can see here, our previous is basically what we'll put in our next now. So this is our head at this time. And then we now set our previous to the same thing. So our previous is now going to be 2 pointing to 1 pointing to null. And then our head is whatever is in our temp, which is going to be 3 pointing to 4. So then our next iteration, we have TMP again. Our TMP is going to be our head, which is 3 pointing to 4. The next item, which is going to be 4. We have our head again, and our head currently starts with a 3, because this is what our head is currently. Our head starts with a 3. Now the next item in our head, we want to replace it with what is in previous, and what was in previous is what? 2 pointing to 1 pointing to null. So 2 pointing to 1 pointing to null. Now that is what is in our head now. So what is in our previous will now be, in our previous, we have what is in our head now. So that is 3 pointing to 2 pointing to 1 pointing to null. And then we have in our head whatever is in our temp, which is 4. So when I go again, our temp is going to be our head, which is 4 pointing to null. The next, which is going to be just null. So in our head, so currently our head is 4, but we want to replace the next item, what was in the next after our head, which is 4. The next item should have been null, but now we are replacing what is in previous, and what was in previous is 3 pointing to 2 pointing to 1 pointing to null. So, and we set this as our previous. So previous is now going to be whatever was in our head, pointing to 3 pointing to 2 pointing to 1 pointing to null. And then we have our head is equals to whatever is in the temp, which is null. And we have a while check, checking if our head is null, and so it comes out of this. And so we see that after the loop breaks out, we see our previous actually holds what will be the reverse, which is 4 pointing to 3, pointing to 2, pointing to 1, and pointing to no, which is exactly what we expect as our output. And that's why we have this approach as we see it here. So basically, this is what the algorithm exactly is trying to achieve. We're trying to replace it in place. We're replacing the items one by one, but we're replacing them in place. So that's why we have like a temporary value just to keep something, we're just trying to map out how the data is passed with from one memory location to another memory location without creating a new data structure that we hold all those things, for example. So this is how we'll go ahead to solve this algorithm. Uh, this is the approach we're using. If you like this video, please like, share, and subscribe, and see you in the next video.